Hi, I'm Dr. Robert Cohen. Today I'm going to show you how to do matrix multiplication on the ACT. Now, I don't know if any of you have tried this soda or remember having had this soda at some point in the past, but RC Cola, and here it is, RC Cola, great taste since 1905, and no, they're not paying me to do this. Is a really good way to remember how to multiply matrices, because in nearly every step of the way, when you're multiplying matrices, involves RC. It involves taking rows before columns. So whenever you get a matrix multiplication problem on the test, just think to yourself, RC Cola. Think of this image, and you should be in good shape. Okay, so now I'll show you how to actually solve these. RC, which stands for rows and then columns, is going to come up all throughout this process. Now, the first thing you need to do when you see two matrices are being multiplied is you need to figure out their dimensions, which might or might not be provided. So the way to figure out the dimension is it's two numbers, right? The first number is the number of rows. The second number is the number of columns in that matrix. So I know it can be confusing. Sometimes it's easy to mix up rows and columns, especially when you're doing a lot of these problems and calculations. So what you can do to remember them, think of a column, just think of an ancient Greek or Roman column on a building like this. Okay, so it's always vertical. So if you get stuck in a problem and say, wait, what's a row versus a column? Just think of ancient Greek and Roman columns, and then you'll never mix these two up. So here's a column. It's the vertical part. So we can see in this matrix we have 3 rows, 1, 2, 3. Then we have 2 columns, 1, 2. Let's look at this matrix. We have 1, 2 rows and 1, 2, 3, 4 of these columns. So that's how you get the dimensions of any matrix. The rows by the number of rows by number of columns, RC. Okay, so if we want to multiply these, then how do we figure out the dimension of the result? When you multiply two matrices, you end up with one matrix. And the way you get the dimensions is by taking the number of rows from the first matrix and taking the number of columns from the second matrix. We pull the rows from the first and the columns from the second. R before C. Same type of thing again. So let's look. How many rows are in the first matrix? 3. How many columns are in the second matrix? 4. So when we multiply these two matrices, we're going to get a 3 by 4 matrix. You can see I've written that out right here. So, it's always going to be these two numbers on the outside that give you the dimensions. As a side note, this probably won't come up on a test, but it could. These two dimensions in the middle have to be the same. Otherwise, the multiplication just won't work out. So you could not multiply 3 by 5 by 6 by 2. These numbers have to be the same. Okay, so now we know we're going to end up with a 3 by 4 matrix. So you just want to draw the matrix and draw little slots as placeholders for the values you're going to fill in. To actually multiply these out, RC is going to come back again. So what you do, you pick, you start with your first slot up here, and you ask yourself, what row and what column is this slot in? Well, what row is it in? It's in the first row. 1, 2, 3. It's in the first row. And then what column is it in? The first. 1, 2, 3, 4. So this is the first row, first column spot. And to multiply, we're going to take the first row, the same row, the first row from the first matrix, and then its column position we take from the second matrix. So we take the row position from the first matrix and multiply it by the column position from the second matrix. The same type of thing again. You're taking a row from the first matrix and a column from the second matrix. R comes before C always. Okay, so let's do this. Let me show you how this works. In the first matrix, the first row is 0 and 1. So we're going to take the first value in that row, 0, and multiply it by, we're going to multiply it by the first value in the first column in the second matrix. So what's that? 2. So 0 times 2. Then we're going to do the same thing again. We're going to take the next value in our first row of the first matrix, 1, and multiply it by the next value in the second matrix, second column, which is 1. Sorry, second matrix, first column. You see how this can be a little confusing, which is why thinking of columns in terms of actual columns, I think, is really helpful. And so basically you add these two values together. So you get 0 plus 1 equals 1. And that's your answer. That is the value for the first row, first column. All right? So I'm just going to work through these, and the best way to, really get comfortable with these types of problems is just to work through a number of them. Let's just go right down the line. Let's take this spot. All right, this is in the first row and the second column. So I take my row from the first row, multiply it by the second column here. So I have 0 times 1, right? 0 times 1 plus what? First row, right? Second column, 1 times 1. So in other words, I have 0 plus 1 equals 1. So I get the same thing. I get 1. All right. Next, we have what's this going to be? This is the first row, third column. First row, so 0 times 0, that's going to be 0, plus first row times third column, 1 times 2, that's going to be 2. So we're going to get 2. We're going to get 0 plus 2 equals 2. This is 2. All right, let's do the next one. First row, fourth column, so 0 times 2 plus 1 times 2. And we happen to get the same thing again. We're just going to get 2. So 0 plus 2 equals 2. And 2. All right, let's keep working. Second row here. Sorry, second row here times the first column in our second matrix. So 2 times 2 plus 3 times 1. So this is the second row being multiplied by the first column. I think I said that incorrectly the first time. So 4 plus 3 equals 7. So this is 7. Okay, here we have the second row multiplied by the second column. So second row, second column, 2 times 1 plus 3 times 1. And we're going to get 2 plus 3 equals 5. So this is 5. Up next, we take the second row by the third column. So 2 times 0 plus 3 times 2. 0 plus 6, that'll be 6. Next, second row again, this time times the fourth column. 2 times 2 plus 3 times 2. 4 plus 6 is 10. We get 10. And I'll finish this up. So typically on the test, you'll have 4 answer choices, and all you'll need to do is figure out the value for 1 or 2 of these slots. And then you'll be able to pick the correct answer based on that limited amount of information, because one slot will, one of the 4 choices that slot will be correct and it will be incorrect in the other 3. So you don't normally have to go through this whole process, but I'm just going to go through it to help you get comfortable with these types of problems. And you should do this a couple of times to really get comfortable with this. All right, so this is the third row. We take the third row from the first one and first column from the second. 1 times 2 plus 0 times 1, that's 2 plus 0, that's 2. 2. Next, all right, third row times the second column. 1 times 1 plus 0 times 1. 1 plus 0 is 1. Sorry, this is make clear that's a 2. All right, next, third row times third column. 1 times 0 plus 0 times 2. That's just going to be 0. 0 plus 0 is 0. And then the third row by the fourth column. So 1 times 2 plus 0 times 2. And that's just going to be, again, 2, as we've seen very often. And there you go. So if I did not make any arithmetic mistakes, that's the correct answer. And that is how you do matrix multiplication. If you liked this video, you can subscribe to our channel for more videos like it.